Welcome to the next lecture on Synchronous Machines course. In the previous class, we have completed our discussion with respect to EMF equation of an alternator. We have seen what is meant by pitch factor, distribution factor, how to calculate EMF equation of alternator. Now, let us try to solve a few questions in this session. Now, look at the first question on your screen. A three-phase, four-pole alternator has 120 slots. The coils are short pitched by one slot. The value of pitch factor will be how much? Very simple question. Let me first note down what is the data given. It was clearly mentioned overall 120 slots are available and machine is having 4 poles and it is a three-phase winding. Now the second part of the question is important. The data is coils are short pitched by one slot. Coils are short pitched by one slot. Then calculate what is the pitch factor is the question. So to calculate pitch factor, we know the formula for pitch factor is equal to cos alpha by 2, where alpha is nothing but short pitch angle. But in the question, short pitch angle is not given directly, but they said coils are short pitched by one slot. That means you see this, suppose if I have a machine where number of slots are available, let us say like this. Imagine this is the starting of the north pole, let us say this is the starting of the south pole. Then what is mean by full pitch? Full pitch means if one end of the coil is started with north pole, the other end of the coil will be exactly under south pole. This is mean by a full pitch. A full pitch means is equal to coil pitch. This is what is exactly mean by a full pitch coil. But here the coil is not full pitched coil, it is a short pitch coil. How much short pitch? It is clearly mentioned coils are short pitched by one slot, exactly one slot. You see, from here you just try to short pitch it by exactly one slot. That means the other end of the coil is not placed exactly on the slot which we thought, and it was placed one slot with a short pitch. Now you tell me this winding is going to be a short pitch winding or full pitch winding? Short pitch winding. How much is the short pitch angle now? This is nothing but short pitch angle alpha. Can I say that alpha is nothing but exactly one slot? Therefore, indirectly I can write that alpha is equal to the angle occupied by one slot. We know the angle occupied by one slot is equal to gamma. Suppose if the data is given like this, let us say coils are short pitched by 2 slots. If coils are short pitched by 2 slots, alpha is equal to 2 gamma. If coils are short pitched by 3 slots, alpha is equal to 3 gamma, like that. It depends on how much slots the coil is shorted. So first your duty is to calculate gamma. What is the formula for gamma? We already discussed. It is 180 degrees by slots per pole. Therefore, it is 180 degrees by overall 120 slots are there with 4 poles. This will be equal to 6 degrees electrical. Now substitute that 6 degrees here because alpha is equal to gamma. So cos 6 degrees by 2, that is equal to cos 3 degrees. Use a calculator. You will get the value 0.998. Okay. Pitch factor is always less than 1 for short pitch coils. Okay, it is 0.998. So remember, always in the questions, short pitch angle may not be given. Sometimes the short pitch may be given in terms of slots. You need to solve like this. Okay. Now let us try to practice one more question. Look at the question on your screen. In a three-phase balanced distributed winding, coils are designed with a short pitch angle of 24 degrees. The value of pitch factor for fundamental harmonic EMF, third harmonic EMF, fifth harmonic EMF. Very simple question. This time the short pitch angle was directly given. How much is the short pitch angle? Alpha is equal to 24 degrees electrical. Now try to calculate what is the pitch factor for fundamental harmonic. We know the formula for fundamental harmonic, it is just cos alpha by 2. Therefore, it is cos 24 degrees by 2, which is cos 12. Find the answer. Similarly, for third harmonic component, what is the formula for pitch factor? We know if fundamental space angle is equal to alpha, for third harmonic the space angle will be equal to 3 alpha. Cos 3 alpha by 2, that is cos 3 into 24 degrees by 2, you will get the pitch factor for third harmonic EMF. Similarly, find out pitch factor for fifth harmonic, cos 5 alpha by 2, which is cos 5 into 24 degrees by 2, you will get the pitch factor for fifth harmonic. Use a calculator, you will get the answers. Okay, simple question. Alright, let us try to solve a few questions related to distribution factor calculations. Look at the question on your screen. Calculate the fundamental, third and fifth harmonic belt factor for a stator having 54 slots, 3 phase, 6 poles. Okay, we have to calculate fundamental, third and fifth harmonic belt factor. Belt factor is nothing but distribution factor. Okay, and first let me note down the data given. 54 slots, 3 phase, 6 poles. Number of slots are equal to 54. Number of poles are equal to 6, and it is a 3 phase winding. We have to calculate what is the distribution factor. What is the formula for distribution factor? We know sin m gamma by 2 by m sin gamma by 2. So to calculate distribution factor, we need m value and gamma value. So let us try to calculate both of them first. What is mean by m? M is equal to slots per pole per phase. Here 54 slots are there and 6 poles and 3 phases are available. So you will get m value equal to 3. Similarly, find out gamma value. To calculate gamma, there are two formulas available. One is direct formula, gamma is equal to 180 degrees by slots per pole. This formula you can use, or you can use one more formula, that is a phase spread. Phase spread sigma is equal to m gamma. I hope you remember this. From this, gamma is equal to sigma by m. And given winding is single phase or two phase or three phase? 3 phase, and we know for 3 phase winding what is the phase spread is equal to 60 degrees. So 60 degrees by what is the m value? 3. Therefore, gamma is equal to 20 degrees electrical. Or you can use this formula also, you will get same answer, 20 degrees electrical. Now we have m value and gamma value with us. Substitute, we will get the distribution factor. And presently, this is the distribution factor for fundamental harmonic, right? So let me substitute the data. Sin m gamma, directly phase spread I can substitute, 60 degrees by 2 divided by m sin gamma by 2. This will give you distribution factor for fundamental harmonic, and the value will be 0.9597. Check with calculator. Okay. Similarly, calculate what is the distribution factor for third harmonic. What is the formula for third harmonic distribution factor? Sin m into, if a fundamental space angle is gamma, for third harmonic it is 3 gamma by 2 divided by m into sin 3 gamma by 2. Just substitute the data. So it is sin, can I write it as 3 into m gamma? That is 3 into 60 degrees by 2 divided by m sin 3 gamma, that is 3 into 20 degrees by 2. Use a calculator, you will get the distribution factor for third harmonic component. Okay, and the answer will be 0.6667. Okay, use a GATE calculator always. Okay, you should have good practice. Always try to calculate denominator first, note down separately, and then numerator by answer. Okay, fine. Next, fifth harmonic distribution factor, same formula, sin m into 5 gamma by 2 by m sin 5 gamma by 2. Substitute the data. Okay, you will get the answer 0.2176. So what is the common thing you are observing here? You see that as the harmonic number is increasing, as the harmonic order is increasing, what is happening to the magnitude of distribution factor? Decreasing. So we know EMF is equal to 4.44 phi ft into distribution factor into pitch factor, right? You see that as the harmonic number is increasing, what is happening to distribution factor value? Decreasing. If distribution factor decreases, the corresponding harmonic EMF magnitude will also decrease. That's why distributed winding will reduce the value of harmonic voltages or will increase the value of harmonic voltages or will not change any value of harmonic voltages. Yes, distribution of the winding will definitely reduce the magnitude of the harmonics. As you go higher and higher harmonics, the magnitude of distribution factor will reduce. Suppose if you calculate, let us say 11th harmonic or 13th harmonic, the distribution factor may be almost equal to 0. If a distribution factor is almost equal to 0, the corresponding EMF is also equal to 0. That's why always remember, distribution of the winding will reduce the magnitude of harmonic voltages. Concentrated winding will not reduce the magnitude of the harmonic voltages. Understand? Alright, let us try to solve one more question. Look at the question on your screen. A 6-pole 50 Hz alternator has 42 slots with 2-layer winding. The flux per pole is 0.012 Webers and each full pitch coil has 8 turns. Determine the phase and line EMFs in case coils are connected to form 2-phase winding and 3-phase star connection. Let me read the data once again. A 6-pole 50 Hz alternator has 42 slots overall and it is a double layer winding. Hope you remember the difference between single layer winding and double layer winding. The flux per pole is 0.012 Webers and each full pitch coil has 8 turns. Determine the phase and line voltages if the coils are designed to form 2-phase winding and 3-phase winding. First, let me note down the data. Yes, number of poles are given, 6-pole, frequency is 50 Hz and overall 42 slots are there and most importantly double layer winding. As it is a double layer winding, we know in a double layer winding, number of coils are equal to number of slots. Number of coils are equal to number of slots. If it is a single layer winding, number of coils is equal to slots divided by 2. Okay. Therefore, I can write the coils are equal to 42. Next, one more information. Flux per pole is 0.012 Webers. Flux per pole 0.012 Webers. Next, each full pitch coil has 8 turns. They said very clearly full pitch coils. Full pitch coils, 8 turns per coil. Okay, each coil has 8 turns. Overall, how many coils are there? 42. And every coil has 8 turns. Therefore, can you calculate how many turns will be there overall? Therefore, total turns are equal to total 42 coils are there. Each coil has 8 turns. Therefore, the total number of turns are equal to 42 into 8 and it will become 336 turns are available overall, complete number of turns. Okay. Now, we are asked to calculate what is the phase EMF and line EMF if the winding is 2-phase as well as 3-phase. Let me do it first for 3-phase and then I will do it for 2-phase. What is the formula for phase induced EMF? We know 4.44 flux per pole, frequency, number of turns per phase into distribution factor into pitch factor. Flux per pole is already given in the data. Frequency is also given. Number of turns are obtained, total 336 turns. But in the EMF equation, these are T is representing number of turns per phase. For 3 phases, if 336 turns are there, for single phase, it will be by 3. Okay. So what are the unknown values here? Distribution factor and pitch factor. So that is our first duty. But here it was very clearly mentioned which type of coils are used. Full pitch coils are used. As full pitch coils are used, pitch factor will be equal to 1 because full pitch means the short pitch angle alpha is equal to 0. If alpha is 0, cos 0 by 2 will be equal to 1. Pitch factor is equal to 1. So we have to calculate distribution factor. To calculate distribution factor, what are the values we need? M and gamma are required. So first calculate M, slots per pole per phase. Overall 42 slots are there and 6 poles, 3 phases. First question I am doing it for 3 phases. Then what is the M value will be equal to? Yes, it will be 2.33. That means it is a fractional slot pitch winding. Yes or not? And what is gamma? You can use two formulas. One is phase spread formula, the other one direct formula for gamma. 180 by slots per pole. 180 by 42 slots and 6 poles, you will get gamma value, and gamma value will be 25.71 degrees. When you know M and gamma, you can calculate what is the distribution factor. What is the formula for distribution factor? Sin M gamma by 2 divided by M sin gamma by 2. Just substitute the data. Sin, can I write M gamma is nothing but directly phase spread. For 3 phase spread is equal to 60 degrees. Divided by M value 2.333 into sin gamma value 25.71 divided by 2. Use GATE calculator. You will get the value of distribution factor and it will be equal to 0.963. That is the distribution factor. Don't forget, I am doing it for 3 phases. Number of phases are equal to 3. Now substitute that distribution factor here, you will get the formula of induced EMF. Okay, so 4.44 into, what is the flux per pole value? 0.012. What is the frequency? 50 Hz. Now this is number of turns per phase. Total 336 turns are there. Then per phase how many will be there? 336 by 3, because I am talking about 3-phase machine. If it is a 2-phase winding, you have to divide 336 into 2 parts. 336 by 2. What is the distribution factor we just got? 0.963. Pitch factor is equal to 1 because full pitch coils. Now if you complete the calculation, yes, the voltage per phase will be equal to 287 volt per phase. This is the voltage per phase, don't forget. For a star connected circuit, if you know per phase voltage, you can easily calculate what is the line voltage, right? So therefore, the line voltage will be root 3 times of phase voltage. So root 3 into 287, you will get what is going to be the line voltage, and it will be 497 volt. Understand? So it is very important to calculate distribution factor first, and then it is also important to understand how many turns are there per each phase. Okay? Now what you do is that do the same calculation for a 2-phase machine. If the winding is connected for 2 phases, then calculate what is the distribution factor. Don't forget that distribution factor will change because I am now going to use 2 phases only. So M value will change. Gamma value does not change because in this gamma formula, are you finding any number of phases? No. Therefore same gamma, but M value changes. So overall KD will change. So use the new formula and find out what is the EMF if the winding is for 2 phases. Let me do it. Okay, if the winding is a 2-phase winding, calculate what is the new M value. M is equal to slots per pole per phase. In the given circuit, 42 slots are there and it is a 6-pole machine, but number of phases are only 2. Therefore, M value will be a different value. Okay, let me tell you the value of M here. Yes, M is equal to 3.5 this time. Then gamma value. Gamma value won't change. 180 degrees by S by P. Therefore, 180 degrees by 42 slots per 6 poles. Therefore, same gamma value and it will be 25.71 degrees. When you know M and gamma, calculate what is the distribution factor. So the distribution factor is equal to sin M gamma by 2 by M sin gamma by 2. Substitute the values. Sine, can I write M gamma is directly phase spread? Or you just substitute the values, you will get the same answer. What is the phase spread for a two-phase machine? 90 degrees by 2 divided by M 3.5 into sine gamma by 2, that is 25.71 divided by 2. You will get the value of distribution factor for a two-phase machine, okay, and it will be equal to 0.908. Substitute that distribution factor here, you will get the voltage per each phase first. So therefore 4.44 into, what is the flux per pole? 0.012, frequency 50 Hz. Now comes to number of turns per phase. As I am considering only two phases, if overall 336 turns are there, then each phase consists of 336 by 2. And distribution factor 0.908. So do this entire calculation, we will get the value of induced EMF per phase first, and it will be equal to 406 volt per phase. If you know phase voltage, then what is the line voltage? Don't tell me root 3 times of phase voltage. That is for 3 phases. It is a 2 phase. We know in a 2 phase circuit, line voltage is equal to root 2 times of phase voltage. So it is root 2 into 406. You will get the value of line voltage, that will be 574 volt per line. So this is how to calculate induced EMF for a 2-phase, 3-phase. Suppose if it is a single phase machine, again M value will change, only single phase 1 you have to use, and you will get another different distribution factor. Use that distribution factor here, and don't forget that T always indicates number of turns per phase. Total 336 turns are there. Per phase how many turns will exist is the question. Okay, fine. Alright, let us try to solve one more question. This is a simple question. Look at the question on your screen. The armature of a single phase alternator is completely wound with T single turn coils distributed uniformly. The induced EMF in each turn is 2 volt. Then what is the total induced EMF? 4 options are given. So it was very clearly mentioned single phase alternator. Okay, single phase alternator. Total how many coils are available? It was clearly mentioned it is completely wound with T single turn coils. Total coils are equal to T, and that too single turn coils. Single turn coils. To calculate induced EMF, I need total coils or total turns. T always represent total turns. Therefore, can you tell me how many turns will be available? Total turns are equal to total coils multiplied by turns per each coil. That's all. Coil will cancel, you will get total number of turns. Total how many coils are there? T, and all coils are single turn coils. Therefore, turns per coil equal to 1. That means total turns are equal to T. If total turns are equal to T, then how many turns will be there per phase? T only. Why? Because the machine is a single phase. Suppose if the machine is a 3 phase, how many turns will be existed for each phase? T by 3, like that. If the total turns are 3, T, the turns per each phase are also equal to T, it is a single phase. Now, another information given here is that the induced EMF in each turn, EMF per each turn is equal to 2 volt. You see, total T turns are there. Each turn has 2 volt. Therefore, can you tell me what is the total voltage? Very simple, like an aptitude question. Total T turns are there. Each turn has 2 volt. Then what is the total voltage? Most of the students will say 2T. But that is wrong. You see, suppose 10 turns are there. Each turn 2 volt. What is the total voltage? 10 turns, each turn 2 volt. It will become 20. Mathematically, it looks correct. But that is wrong answer. Why? Because T turns with 2 volt per turn means you are doing algebraic calculation. 2 plus 2 plus 2 plus 2, like that. T times if you do, you will get 2T. This is algebraic calculation. Algebraic calculation. But we also know that winding is a distributed winding. So whenever you do algebraic summation, that is nothing but a concentrated winding value you got. Now multiply this concentrated winding with distribution factor, then you will get the exact answer. Okay. Now this is going to be vectorial summation. Okay. Yes. Given machine is a single phase or three phase or two phase? Single phase. I hope you remember the approximate value of a single phase distribution factor. Yes. For single phase distributed winding, what is the approximate distribution factor? That is 2 by pi. Therefore, what is the final answer? It is 4 by pi t volt per phase. This is the final answer. Okay. So most of the students will definitely select 2t, but that is wrong answer. That is also there in the options, but that is wrong. So always remember, t turns 2 volt per turn. It looks like 2t, that is fine, but that is algebraic summation, like a concentrated winding. Suppose if I say a transformer has t turns, each turn has 2 volt, then the answer 2t is correct, because transformer will have concentrated winding. But for alternator, we will use a distributed winding, so you have to multiply that concentrated winding voltage with distribution factor, then only you will get correct answer. And the approximate value of distribution factor for a single phase machine, 2 by pi. For three phase machine, what is the approximate distribution factor? 3 by pi. For two phase machine, 2 root 2 by pi. We already did the derivations. Okay. So this is the answer. So these kind of questions will come for 1 mark. Okay. Alright, let us try to practice one more question. Look at the question on your screen. A 3-phase 16-pole alternator has a star-connected winding with 144 slots and 10 conductors per slot. The flux per pole is 0.03 Webers. Speed is 375 RPM. The magnitude of phase EMF is how much? So first let me note down the data what is given. It was mentioned 3-phase 16-pole, okay, alternator, star connected, okay, this is another information, and 144 slots are there. Total number of slots are equal to 144, and 10 conductors per slot. This is important. 10 conductors per slot. Speed is given. What is the speed? 375 RPM. Now, what is the magnitude of induced EMF per phase is the question. What is the value of induced EMF per phase? Now, to calculate induced EMF per phase, what is the formula? 4.44 phi F, number of turns per phase, into winding factor. That is the distribution factor multiplied by pitch factor. Now, flux per pole is given or not given? Yes, flux per pole is given. I forgot to mention. Flux per pole is 0.03 Webers. Yes, flux per pole is already given. Frequency is not given, but from the speed I can calculate frequency. Number of turns per phase are not given. This is the first calculation we have to perform. Then calculate distribution factor. Then calculate pitch factor. Substitute here, you will get the answers. So, what is the formula for frequency first? When speed is given, frequency is equal to P into N by 120. It was mentioned 16-pole machine rotating at 375 RPM by 120. This will be equal to 50 Hz. Don't blindly substitute 50 Hz. Calculate it and then substitute. We got frequency. What is the next value we have to calculate? Number of turns per phase. To calculate number of turns per phase, first I need to know how many total turns are there. But in the given question, slots are given, conductors per slot are given. That means I will first get the total number of conductors. When you know number of conductors, you can easily calculate number of turns. Let us see this. Total conductors is the first question. Total conductors. Yes. Overall, how many slots are there? 144 slot. Each slot has how many conductors? 10 conductors. Therefore, total conductors are equal to 1440. When you know number of conductors, can you calculate number of turns? Because we know one turn requires 2 conductors. In that case, can you tell me total turns will be how many? If one turn requires two conductors, then 1440 conductors can prepare 720 turns. Am I correct or not? Okay. If two conductors form one turn, 10 conductors will form 5 turns. Like that, 1440 conductors will form 720 turns. But in the question, we need total turns or turns per phase. Yes, calculate turns per phase. Yes, we are using a 3-phase machine. So total 720 turns are there divided by 3. Okay. So the answer will be 240 turns per phase. Okay. So we got T value, turns per phase, 240. Then what is the next calculation? Distribution factor and pitch factor. But to calculate pitch factor, we need short pitch angle. But in the entire question, there was no information regarding short pitch angle. Okay. Therefore, I can assume the machine is a full pitch winding. That means pitch factor will be equal to 1. I hope you understand why I took it as 1. To calculate Kp, we need short pitch angle alpha. And there is no information in the question regarding short pitch angle. That's why I am assuming it as a full pitch and I calculate it as 1. Then what is another value we need? Kd. To calculate a distribution factor, we need M and gamma values. Okay, try to calculate M first. M is slots per pole per phase. Overall, 144 slots are there. 16 poles and it is a 3-phase winding, so you will get M value and it will be equal to 3. Then gamma value. Gamma 180 degrees by slots per pole. This is equal to 180 by 144 slots with 16 poles. You will get gamma value and let me tell you the value of gamma. Yes, it will be equal to 20 degrees. Okay, you can check. Once you know M and gamma, you can calculate distribution factor. Distribution factor is equal to sine M gamma by 2 divided by M sine gamma by 2. So this is a sine. M gamma is phase spread. As it is a 3-phase, I can directly substitute phase spread 60 degrees by 2 by M value 3 into sine gamma by 2, that is 20 by 2. You will get the value of distribution factor. Okay, and it will be 0.9597. When you know distribution factor, substitute here, you will get the value of voltage per phase. Okay, I am leaving that final calculation for you. Substitute and find out the value of voltage per phase. The answer should be approximately 1533 volt. Okay, substitute and get the answer. Alright, simple question. Alright, let us try to practice one more question. This is important model. Look at the question on your screen. A 50 Hz salient pole alternator has fundamental peak flux density of 1.102 Tesla. This alternator has the following data. Total turns 360, phase spread 60 degrees, pole pitch 0.6 meters, stator length 0.8 meters, coil span 180 degrees electrical. The RMS value of fundamental EMF per phase is how much? Okay. So first let me note down the data what is given here. First it is mentioned 50 Hz frequency 50 Hz. Next, salient pole alternator. Fundamental peak flux density is given. Okay, fundamental peak flux density is equal to 1.102 Tesla. This time flux per pole is not given directly, but flux density is given. From the density you have to calculate what is the flux per pole and then find out the EMF. But for that, what are the additional data given? Total turns 360. Total turns 360. Next, phase spread 60 degrees. Phase spread 60 degrees means definitely it is a 3-phase winding. Okay. Suppose if phase spread is 90, 2-phase, 180 single phase. Okay. Next, pole pitch 0.6 meters. Pole pitch 0.6 meters. Stator length, that is indirectly the axial length, is equal to 0.8 meters. Coil span beta is equal to 180 degrees. Can you tell me what is your observation? Coil span or coil pitch is equal to 180 degrees means indirectly full pitch coil. Therefore, short pitch angle is 0, pitch factor equal to 1. What is the phase EMF is the question. Okay. Alright. Now, to calculate induced EMF, what is the information we need? 4.4 phi F number of turns KD KP. In this, frequency is already given. Number of turns information is already there. KD and KP we can calculate because the formulas are directly available. M and gamma values are available means you can calculate. So the only unknown here is flux per pole. To calculate flux per pole, flux density information is given. Yes, the last portion of the previous lecture, I told you how to calculate flux per pole when density is given. What is the formula? Flux per pole is equal to 4 by P into maximum flux density into length into radius of the magnetic core. I hope you remember this formula. Already the maximum flux density is given. Axial length of the core is also given. What is the length? 0.8 meter. Therefore, the only unknown here is radius and number of poles. So, to calculate radius and number of poles, I must use this information. Pole pitch is equal to 0.6 meters. So, how do you calculate pole pitch and radius and P, all this information? Okay, you see, suppose, assume it was mentioned salient pole machine. Assume this salient pole has, let us say, 4 poles like this. Okay, this is how the rotor circuit looks like. Okay, that dotted line is assuming like a circle, but actually it is a salient pole machine. I assumed 4 poles. You can assume even 400 poles also if you are able to draw the diagram. Now this is north pole, south pole, north pole, south pole. This is the rotor part. Above this rotor, we have a stator magnetic circuit, and overall it looks like a cylindrical circuit. Okay. To avoid that confusion, let me remove them. Now, it is clearly mentioned pole pitch length is given. What is mean by pole pitch? Can I say pole pitch is nothing but the length from north pole to south pole to adjacent north pole to, this is north pole position, this is south pole position. Can I say this length is nothing but equal to 0.6 meters? Okay, that is nothing but pole pitch. Now, this is like a rotor magnetic circuit, right? Salient pole rotor magnetic circuit. For this rotor, can you tell me what is this distance? Center to the end of the circle, can I say that is a radius? If you know this is radius, what is the entire length of this circle? Entire length of this circle means, can I say perimeter? So perimeter is equal to 2 pi r. If the perimeter is equal to 2 pi r, then what is the length occupied by each pole? Therefore, pole pitch is equal to, you see, the total length is 2 pi r, then what is the length occupied by each pole? Very simple. Total length divided by 4 in this case. Why? Because I assumed 4 poles. Suppose if it is a 2-pole machine, total circle length divided by 2. Suppose if it is a 6-pole machine, total circle length divided by 6. If it is a p-pole machine, total length divided by p. Total length is 2 pi r divided by number of poles p. First of all, you tell me what is 2 pi r? 2 pi r is the total circle length, perimeter. If the total circle length is 2 pi r, per pole how much is the length? Divided by p. This is nothing but pole pitch. And in the given question, pole pitch is equal to how many meters? 0.6 meters. Can you separate r by p from this? Yes, r by p is equal to 0.6 by 2 pi. Now directly substitute that r by p here. Okay. So it is 4 is here. Maximum flux density 1.102, axial length 0.8 meters. Now r by p, directly I can substitute 0.6 by 2 pi. This will give you flux per pole value. Okay. let me tell you, this becomes 0.3367 Weber per pole. When you know flux per pole, now you can use EMF equation and find out the answer. I will leave that EMF equation part for you. I found flux per pole and I am handovering this problem to you. You have to complete the calculation, calculate distribution factor. Pitch factor is anyway equal to 1. You will get the formula of induced EMF, value of induced EMF. And let me tell you the answer. You should get 8566 volt per phase. Okay, that's all. So the simplest thing is when pole pitch length is already known, how to relate it for a p-pole machine. Whatever may be the machine, the total circumference of the circle is equal to 2 pi r. 2 pi r divided by number of poles will give you pole pitch. That's all. And from the pole pitch, I substituted the data here and I got a flux per pole. So it is very important whether you remember this formula or not. This formula everybody will remember. But this formula, whether you remember or not, based on that you can get the answer for this question. So this is an important formula to be remembered. Okay. You must write this formula in your short notes and repeat it whenever you have free time. Okay. Alright, let us try to practice one more question. Look at the question on your screen. A 3-phase 6-pole 1000 RPM alternator has an air gap diameter of 28 cm and a core length of 23 cm. Phase spread is 60 degrees. The winding is accommodated in 4 slots per pole per phase with 8 conductors per slot. The coils are short pitched by 1 slot. When the flux density wave is analyzed into space harmonics, the fundamental is found to have an amplitude of 0.87 Tesla and third and fifth harmonics to have an amplitude of 0.24 Tesla and 0.14 Tesla respectively. If armature winding is star connected, the resultant line voltage is how much? So it's a lengthy question. It was a previous IES examination conventional paper question. But for GATE examination, this much lengthy question may not come, but any part of this question may come. So why I pick this question is this question will deal with harmonic voltages also. Okay. So first let me note down the data what is given and let us try to find out what is the answer required. It was clearly mentioned 3-phase 6-pole 1000 RPM. Okay. 3-phase, number of poles are 6, speed is equal to 1000 RPM. From these two you can find out frequency. 6-pole NS 1000 means frequency could have been equal to 50 Hz. Air gap diameter is given. Air gap diameter is 28 cm. If diameter is 28 cm, radius is equal to 14 cm. Core length, that means axial length is given. What is the axial length given? The axial length is 23 cm. They need not to mention specifically axial length. Whenever I said core length or pole length, that means axial length, 23 cm. Phase spread 60 degrees, that is anyway we know. Next thing, the winding is accommodated in 4 slots per pole per phase. That means M value is equal to 4. With 8 conductors per slot. Another information, 8 conductors per slot. Next, coils are short pitched by 1 slot. Short pitched by 1 slot. That means you can calculate what is pitch factor. Next, when the flux density wave is analyzed into space harmonics, you see flux density is given. Fundamental flux density B1 is equal to 0.87 Tesla. Third harmonic flux density, that is equal to 0.24 Tesla. Fifth harmonic flux density is equal to 0.14 Tesla. Okay, these are the maximum values of individual harmonic flux densities. What is the final answer we need to discuss? What is the line voltage produced if the machine is a star connection? So see here, the concept is Fundamental flux is there, third harmonic flux is there, fifth harmonic flux is there. Therefore, obviously, E1 will induce, E3 will induce, E5 will induce. When all three harmonic voltages are there, then what is the resultant voltage? I hope we studied in transformers also. When fundamental harmonic, third harmonic, fifth harmonic all are existed, then I can write resultant voltage is equal to square root of E1 square plus E3 square plus E5 square. I hope you remember this formula. Suppose if a seventh harmonic is also there, I have to include E7 also. But the final answer we need line voltage. Did you remember in any star connected circuit, the line voltage do not have third harmonic voltages? Yes or not? Therefore, there is no need to calculate third harmonic EMF. I can neglect third harmonic component because we are asked to calculate phase voltage or line voltage. Line voltage. Suppose if we are asked to calculate phase voltage, then third harmonic EMF must also be considered. Because under one phase, third harmonic EMF may be there, but coming to the line, third harmonic EMF is absent. So, our ultimate aim is to calculate fundamental phase voltage and seventh harmonic phase voltage, then finally find out line voltage. To calculate voltage of each harmonic, first we need what is the flux per pole. Here, density is given. From the density, we have to calculate flux per pole. When I know flux per pole, then calculate distribution factor and pitch factor for each harmonic. Then finally calculate what is the EMF. Okay. So first let me try to calculate flux per pole from the density values. Alright. So to calculate flux per pole, I will use this formula. Phi is equal to 4 by P into Bm into L into R, where Bm is the maximum values. This is the formula for fundamental flux component. Therefore, this is a fundamental flux density. So 4 by how many poles are there? 6 poles. What is the fundamental flux density? 0.87 into what is the axial length? 23 centimeters. That means 23 into 10 power minus 2 meters. And radius is 14 centimeter. That is 14 into 10 power minus 2 meters. You will get fundamental flux per pole. This is the first calculation. Next. Fifth harmonic flux per pole, let me tell you the answer here. It is 0.01867. This is the fundamental flux per pole. Next, coming to the fifth harmonic flux per pole. Why third harmonic I am not calculating? Because ultimately we need line voltage. Line voltage do not have third harmonic EMF component, right? Okay. Fifth harmonic. You see, when you know fundamental flux per pole formula, fifth harmonic flux per pole formula you can easily develop. Why? Because we know already, we studied many times in harmonics. If a fundamental harmonic create P number of poles, fifth harmonic can create how many number of poles? 5 into P. Yes or not? Therefore, 4 by 5 into P into fifth harmonic flux density into LR. Did you understand why I wrote 5P here? Yes. So therefore, let me substitute 4 by 5 into 6 poles. Yes, what is the fifth harmonic flux density? 0.14 into axial length 23 centimeter into radius 14 centimeter. You will get the fifth harmonic flux per pole, that will be equal to 0.000601. You see that 0.000 means almost equal to 0. That means indirectly fifth harmonic flux can be neglected, okay, ideally. But strictly speaking, some small value is there. Let us consider it and complete the problem continuously, okay. Yes, we got flux per pole value. Now our next discussion is calculate winding factor for fundamental and fifth harmonic, okay. Let us do it. Alright, let me try to calculate pitch factor first. To calculate pitch factor, I need short pitch angle. It was clearly mentioned in the problem. Coils are short pitched by one slot. As coils are short pitched by one slot, can I say indirectly alpha is equal to one slot angle, that is nothing but gamma? Suppose if it is given that coils are short pitched by two slots, then alpha is equal to 2 gamma, right? So here first try to calculate gamma. We know formula for gamma is 180 by slots per pole. This is 180 by how many slots are given in the question? Yes. Slots per pole are not given directly, but M value is given, right? Yes. What is the M value given? 4. Yes. When you know M value, how to find out gamma? Phase spread you can use. Phase spread is equal to M gamma. From this, gamma is equal to phase spread by M. Therefore, gamma is equal to 50 degrees. Okay, that's all. Substitute. Therefore, alpha is equal to 15 degrees indirectly. When you know alpha, what is the pitch factor for fundamental harmonic? Cos alpha by 2. Therefore, cos 15 degrees by 2. That means cos 7.5. It will be 0.99144. That is the pitch factor for fundamental harmonic. Similarly, calculate the pitch factor for fifth harmonic. Third factor we need not to do it. For fifth harmonic, it is cos 5 alpha by 2. Cos 5 into 15 by 2. Use a calculator. You will get pitch factor for fifth harmonic. It will be 0.793. Done. One part is done. We calculated pitch factor. Note this down and then we will proceed to calculation of distribution factor. Okay. Yes. What is the formula we know about distribution factor? First, for fundamental harmonic, sin m gamma by 2 divided by m sin gamma by 2, right? M gamma is directly phase spread. Substitute the values. Sin m gamma 60 degrees by 2 divided by m value 4. We just calculated gamma, that is 15 degrees by 2. This will give you distribution factor for fundamental harmonic. Let me tell you the answer here. Yes, it will be 0.9576. Similarly, calculate the distribution factor for fifth harmonic also. I hope you remember the formula. Sin m into 5 gamma, that means indirectly 5 m gamma by 2 divided by m sin 5 gamma by 2. So substitute the answer. 5 into 60 degrees by 2 divided by 4 sin 5 into 15 degrees by 2. This will give you the distribution factor for fifth harmonic and it will be 0.205. When you know pitch factor and distribution factor for both harmonics, now you can calculate what is going to be the induced EMF for each harmonic. But to calculate induced EMF, what are the data we need? 4.445 F number of turns KD KP. Okay. KP value we calculated, KD value completed, flux per pole also we calculated, frequency is known 50 Hz because from the speed and poles. The only unknown here is number of turns per phase. Let us see how to calculate number of turns per phase. Okay. All right. To calculate number of turns, what is the information available? M value is available 4 and they said 8 conductors per slot. So what my first intention is, as number of conductors per slot are given, suppose if I know total how many slots are available, I can get total how many conductors are available. When we know how many conductors are available, from that we can calculate how many turns are available. So try to find out how many overall slots are available in the given machine. We know formula for M is slots per pole per phase, right? From this, number of slots are equal to M into poles into number of phases. M is 4. How many poles are there? 6 pole and it is a 3-phase machine. You will get a total number of slots. Let me tell you. Yes, total slots are going to be 72. And every slot has how many conductors? 8 conductors. Therefore, can you tell me how many total conductors are available first? Yes, total conductors are equal to total 72 slots into 8 conductors per slot. We will get total how many conductors are available. It will be 576 conductors overall. When you know total conductors, how many turns are possible? Because one turn will have 2 conductors. Therefore, total turns are equal to 576 by 2. Okay, that will be equal to 288 turns. If overall 288 turns are there, then per phase how many turns will be there? Therefore, number of turns per phase are equal to 288 by 3 because it is a 3-phase machine. Therefore, per phase 96 turns will be available. That's all. So when you know per phase number of turns, now we are available with all the data so that I can calculate fundamental EMF, fifth harmonic EMF, and then I can find out what is the line voltage. Okay, let's see. Alright, let me try to calculate fundamental EMF first. 4.44 into fundamental flux, fundamental frequency, number of turns, fundamental distribution factor, fundamental pitch factor. All values are available with us. Voltage per phase. Let me substitute. 4.44 into what is the fundamental flux we got? 0.01867. Fundamental frequency 50 Hz. How many number of turns per phase? 96. And what is the distribution factor for fundamental harmonic? Let me see the answer we got. 0.9576. What is the pitch factor for fundamental harmonic? 0.99144. All the values we already calculated. I am just substituting them. So if you do this, you will get a fundamental EMF per phase. Okay, and it will be equal to 377 volt per phase. Fundamental EMF. Next. Similarly, calculate fifth harmonic EMF per phase. Same formula, 4.44 into, but I have to substitute fifth harmonic flux per pole. Next thing, frequency. If fundamental frequency is F, fifth harmonic frequency will be equal to 5F. Next, number of turns, fifth harmonic distribution factor, fifth harmonic pitch factor. That's all. You understand the variations in the equation? This is a fifth harmonic flux, fifth harmonic frequency, fifth harmonic distribution factor, fifth harmonic pitch factor. So 4.44 into what is the fifth harmonic flux we got? 0.000601 into 5 times of 50 Hz. Number of turns per phase are 96. Yes, what is the distribution factor for fifth harmonic component? Yes, it will be equal to 0.205. Pitch factor also we calculated 0.793. If you do the entire calculation, you will get fifth harmonic EMF per phase and it will be 10.42 volt per phase. You see here, fundamental EMF is 377. Fifth harmonic EMF is just 10. So harmonic voltages will reduce as the order is increasing. When you know per phase values, how to calculate line values? Fundamental voltage per line is equal to √3 times of phase voltage. That is √3 into 377. This is fundamental line voltage. Similarly, fifth harmonic line voltage, √3 times of fifth harmonic phase voltage. That is √3 into 10.42. You will get fifth harmonic line voltage. Then what is the resultant line voltage finally? Resultant line voltage is square root of E1 square plus E5 square. If say there is seventh harmonic, E7 square also you need to add. So if you do the entire calculation, it will be 653 volt per line. Check your calculations. First convert this phase voltage to line, this phase voltage to line, then add both of them like this, E1 square plus E5 square, then you will get the line voltage. Okay, that's all. So these are the various types of numerical questions from EMF equation. Every problem I have selected here is important for the examination point of view. Different models we solved. When flux per pole is directly given, problem becomes very simple. But when flux density is given, you have to find out flux per pole using the formula 4 by P into, what is the formula? 4 by P into BLR. This is for fundamental. For third harmonic, 3P. Fifth harmonic, 5P. Like that you have to substitute. Okay. Let me conclude the lecture here. In the next lecture, we will start the discussion regarding armature reaction in synchronous generator. Okay. Thank you.